will discuss with the experiment number 8. The problem statement goes like this. Consider a scenario where you want to take a printout of few selected random pages in a sequence numbered from 0 to 5. Design a circuit to achieve this task using JK flip-flop. So the basic component that are required to accomplish this experiment is a digital trainer kit, IC 7476 and patch cards, but we are using the online simulator which is Deltsim, where physical digital trainer kit is not required, patch cards are also not required. Along with this, you need one AND gate with the number 7408. So you are all very much aware of designing the counters. So for designing a counter, you need excitation table with respect to JK flip-flop, and at the same time, what is the counting sequence that is to be generated. So that is to be written carefully in this experiment. By looking into the state transition diagram, the counting sequence starts from 0, 0, 0 and it is moving to the next state, which is 0, 0, 1. From 0, 0, 1 to 0, 1, 0. Next 0, 1, 1. From there it is 1, 0, 0. Finally ends up with 1, 0, 1. So if you represent that in decimal, then it is moving from 0, 1, 2, 3, 4, 5. Once again it is coming back to 0. So for this counting sequence generation, we have presented a procedure for getting the final expression for designing this sequence using JK flip-flop. So you are all familiar with designing the counters. So it's a part of the counter design process. So everything is been mentioned clearly under this section. Finally, we'll get a circuit diagram for a given expression, and based on the circuit diagram, we will accomplish or we will realize whether we are getting the same sort of output with the help of Deltsim simulator. So this is the circuit diagram. According to this circuit diagram, you have to make a connectivity. So we will switch to a Deltsim simulator. So now we can able to see the Deltsim simulator environment. So first we should reset the entire circuit, and the ICs required are JK, that is 7476, and the another one IC is your AND gate. The number here is 7408. So you need 3 JK flip-flops and 1 AND gate. But for clear monitoring and viewing the things, so I am going to connect 3 JK flip-flops in the IC base 1, 3 and 5, and 2 AND gates will be connected to IC base 2 and 4. Let's add an IC. So first base is connected with the JK flip-flop, that is 7476, and third IC base is connected with once again a JK flip-flop 7476, and the last IC base, that is 5, is also connected with 7476. So I have added all the 3 JK flip-flops. Now I need to add AND gate, that is 7408 to IC base 2, and once again AND gate, so 7408 to IC base 4. First, what you need to do is you connect all VCC and ground for all the ICs. As you already know that 7476 is a 14 pin IC where 5th pin is VCC and 7476 is 16 pin IC where 5th pin is VCC and 13th pin is ground. In case of 7408, 14th pin is your VCC and 7th pin will be ground. Now I'll connect all the VCC and ground connectivity with respect to all the ICs. So first IC is 7476. So here 5th pin is VCC, and in the third IC base once again I am using 7476. So 5th pin is VCC, and for the 5th IC base also we are having the 5th pin as VCC. So I am not done with the AND gate. So for AND gate 14th pin is your VCC. So you have used two AND gates, that's why you have to do a two connectivity separately. So now we can able to see for all the ICs we have connected or we have established VCC connectivity. Now I have to do with grounding. So for 7476 IC, pin number 13 is ground, and for 7408 pin number 7 is ground. So here 7476, so 13th pin is ground, and here you are using AND gate, so that is 7th pin is ground, and lastly you are using 7476, so that's why it is ground. So for JK flip-flop you have two inputs, two outputs. Pin number 4 is inputting J value and pin number 16 is inputting K value. So output of first flip-flop is Q, that is from 15th pin, and Q complement from 14th pin, and you have additional 3 inputs which you need to know. One is clear all the ICs, and the second one is preset, and third one is clock. So before that you should remember that 7476 consisting of 2 JK flip-flops, means which is fabricated within a single IC, but in this experiment I am making use of only one JK flip-flop from each and every 7476 IC. So as you already know that by looking into the data sheet, so a pin number 1, pin number 2 and pin number 3 all are considered to be the negative edge trigger. So that's why you have to, if you want to make this IC to work, so you have to keep preset and clear to high. So if you are making it low, it won't work. So if you keep high, then only it will work according to the JK flip-flop. So for clear, so we are supposed to use pin number 3, and for preset you are supposed to use 3. So I will combine 2 and 3 and I will give it to the input section, that is pin number 0, and I'll keep this input to high. So just observe. So from first JK flip-flop I am giving it to input section 0, and from third also I am giving it to 0, and I keep this input line to high. So first flip-flop I made IC clear, and means I have done the connectivity with respect to clear and preset. So you have to repeat the same thing for IC number, that is flip-flop 2, that is resides in third IC base. So from 2 to first input section, that is 0. So 3 is once again clear, which is kept high. Lastly for the last flip-flop, I have to give clear and preset to high. After that, so pin number 1 is clock, which is to be given from the frequency line. So that is, you have different frequency, that is 10, 5, 1 and 0.5. I will making use of this as a clock pulse. So for a 7476 IC, pin number 1 is a clock. So I have connected this frequency line to 1, means it has to be triggered in a uniform interval. So next, for the second 7476 IC, I have given a clock input, and for 7476 third JK flip flop, I have given a clock input. So now we have done with clock, clear, preset, VCC and ground with respect to all the JK flip flops. Next, look into the connection. If you look into the circuit diagram, pin number 15 is the output, whereas 4 and 6 are considered to be the 4 and 16 are considered to be the input. So for the first flip flop, that is for J and K, where according to the solution you identified that, so it should be high, means JA and KA should be high. So that's why for pin number 4, I am giving an input, that is 4 is J, and I am keeping that input to high, and for pin number 16, once again that is connected to high itself. So please remember, for the first flip flop, J and K value remains 1. So 1 means it is a high voltage. So you can observe, so 4 is a bold line which is connecting from input section 1, pin number 1, and I kept pin number 1 to high, as well as for 16 also I have kept the input line to high. After that, so you are getting a connectivity, means input has been given. So output of the first flip flop is considered as one of the output. So that output we can call it as A, and that is connected to output section pin number 0. So you have to remember that. So from first flip flop, there are 5 connectivity which has been established. So that is one connectivity to your output line. The second is for first AND, one connectivity to first AND gate, second connectivity to second AND gate, and third connectivity to the second flip flop kth pin, that is pin number 16, and fourth connectivity from for the third flip flop K input. So please remember, so one output line I have given. So from second output is, so from 15 I have to connect the pin number means AND gate second input. For AND gate first input, it is the complement of the third flip flop. So complement of third flip flop means it is getting from pin number 14. So that's why from 14, third flip flop 14 pin to AND gate, first AND gate I have connected. So 2 connectivities are done from the output of the first flip flop. One is to AND gate and another one is to output line. The third connectivity from pin number 15 of first flip flop to the second AND gate, and the same time, so pin number 15 from the first flip flop to 16 pin of your second IC, as well as from pin number 15 to 16th pin of third flip flop. So all the 5 connections which are moving from 15 pin, we have done it. So at the same time, for the first AND gate, you have two connections. One is C complement and the other one is output of the first flip-flop. So the output of the first AND gate should be connected to the second flip-flop J input, that is 4. And at the same time, output of the second J flip-flop is considered as B. And at the same time, from the same line, that is pin number 15 of second flip-flop, you have another one input which is already been established. So you can suppose you can do it. So output of the second flip-flop is connected to the first one. Next, the output of the second AND gate will be once again the input for the third flip-flop J line, that is pin number 4. So with this, we have done with all the connections. We have to verify the output. So once again, the output of the third flip-flop will be your C. So you just connect it to the output section. So 0 is from output of first flip-flop, 1 is output of second flip-flop, and 2 is output of third flip-flop. So now you switch on the simulator. Before that, you make high with respect to frequency. Preset and clear should be high, and J and K input first flip-flop should be high. So you switch on the power and you monitor. So you can observe now from initial value 0002 it changes to 01, next 10, next 11, next 100, next 101. After 101, it is once again going to 000. So you can watch the things carefully. So it is moving from 000 to 0101, and after 101 it is once again moving back to 000. From this, we can easily realize the designing of a counter from the counting sequence 0 to 5 using a simulator. So thanks for watching. Thank you.